Hello, welcome back to the second part of the chapter 5, which is second part of chapter 5 is about forward method. So let's us imagine that we are having the continuous variable, and again we are using the normal distribution for our continuous variable, and for that continuous variable we want to know the probability of having something number. Let's say I give you this situation. Let's say about the height. So we know that for the height, we are having the mean of the height is 160 cm, and let's say the variance of the height, the population variance of the height is let's say it is 25 cm. Okay, so whenever we have population variance, automatically we can have population standard deviation, which is we need to square root population variance. So we square root 25, so we will come up with 5. So that 5 is population standard deviation. So we have population standard deviation, which is 5. And then using this information, so we want to know from this population that we have, so we want to know what is the probability that the people having the height which is shorter than 175 centimeter from the population that having that distribution of the height. So now when we want to know about the probability using the real situation, real variable, so again when we are working with the continuous variable, to know the probability, so still we need to use the standardized normal distribution to calculate for probability. So when we need to work with the standardized normal distribution, from the real variable, which is the real variable which is about the height, to convert into the standardized normal distribution, we need to transform first our real variable value into the z-score. Then we can use the standardized normal distribution. Then we can use the table of the SND to calculate for probability, which is how to transform into the z-score from the real variable value into the z-score. We are going to use this formula, which is given to us as z equals to x minus mu divided with sigma, which is z is the z-score, x here represents the value of the real variable that we want to know. So let's say just now in the example that I gave you, what is the probability that the people having the height less than 175 cm. So 175 cm is in terms of our real variable, which is the height. So that is our value of the real variable. So that is our value of the variable that we want to know the probability. Alright, whereas the mu here is the population mean value. So I write it as a short form. So POP stands for population. And then the sigma here represents the population standard deviation. Alright, so then whenever we have all the information, we substitute into this formula. Then we have the z-score. Then we can use the table, SND table. Then we can find the probability value. Alright, okay, so let us go to the example so that we can know how to actually we transform from the real variable into the z-score, and then use the table of SND table and find the probability. Alright, so using the example 1, it says that a random variable is given x and in bracket 50 with 16. Now we know whenever it's given to us x and then we have n with 50 and 16. So now we know whenever we have x here represents our variable. And then we have here n. So whenever we have n here, automatically we know this one is normally distributed. So when normally distributed, automatically we know this variable is continuous variable. And to calculate probability, we are going to use normal distribution probability. Alright, and then again, we know this one is the notation or the model of the normal distribution model, which is the notation or the model for normal distribution given to us with x normally distributed with mu, which is population mean, and the sigma square, which is population variance. So when we have population variance, automatically we can have population SD, which is to come up with population SD, we need to square root population variance. So now we know in this case, our population mean, which is a mu, is 50. Our standard deviation, population standard deviation, which is sigma, because we are going to use population SD in our formula. So we are going to go back to the formula again. So we are going to use population SD, not population variance in the formula. So we are going to use population SD, which is sigma. So we need to square root the value given to us in the bracket, because the value in the bracket is population variance. So we need to square root the value, which is we square root the variance. So population SD is going to be 4. Square root 16 is 4. So population SD is 4. So we have this information. Then we can transform whatever value that we want to find the probability into z-score. Then we can use the SND table to find the probability. Okay, so the first question, calculate Px less than 53. So in this case, whatever we want to find, let's say x here is about the weight, let's say. The x variable is about the weight. So the first question, calculate probability, the weight less than 53 kilogram. Alright, so what we want to know here is Px less than 53. Okay, alright. So we know that we need to transform x into z so that we can use the SND table. Using the formula z equals to x minus mu divide with standard deviation. We divide with sigma. Alright, okay, so the same thing, this one, we need to transform into z. So what we are going to have is P. Now we transform to z, so x, we are no longer going to have x. Now we are going to have z. Okay. For the symbol, we are going to use the same symbol with the question that we have. So this one is less than, so we're also going to have less than. So z less than. Now, substitute the value into the formula. So the formula we have is x. X is whatever the value we have in the question. So the question we have is 53. So we substitute the value 53 minus, and then we have mu. So mu is the population mean. So from the question just now, we have the mu, which is 50. So we substitute, we have 50. And then divide with sigma, which is sigma again from the information we have is 4. So we have here is 4. Okay. So after we substitute, so now we can calculate for the value of z. So we have 53 minus with 50. Then divide with 4. So we will have 0.75. So that is our value of z. So P z less than 0.75. Okay. Now we have the z value. So always, whenever we have the z value, so always draw the standardized normal distribution with the shaded area for our probability value. Alright, so our standardized normal distribution with the mean of 0. So value of Z score 0.75 is positive. So it's going to be on the right side. So this one is going to be on the right side. So 0.75 is here. And then shaded area. So shaded area says that less than the value of 0.75. So means that it is on the left side of 0.75. Okay. So again, now when we compare this shaded area with our table to find the probability, it is the same shaded area with our table. So meaning that we can just straight away look into the table for probability value. So again, refer to our table. Okay, so again, refer to our table. So 0.75, so first decimal, first column. So 0.7, first column. 5, second decimal, first row. So 0.75 probability, we are going to have 0.75 is here. So meaning that, So meaning that our probability is going to be 0.7734. So now our answer, we are going to have probability is 0.7734. So that is our answer. Probability of X less than 53. Okay, now for the second question, the question is Px greater than 60. So again, the same thing. The question is for the probability of X. So again, we need to transform X to Z so that we can use the SND table. So the same thing, using the same formula, X minus mu divide with the sigma. So our X value is 60. So still our mu and the standard deviation is the same value. Mu is 50, sigma is 4. So we substitute into the formula. So we are having P. Now we transform into Z. We are no longer have X. We are having Z. Use the same symbol, which is greater than, and then 60. So we have X is 60. Minus with our mu, which is mu, again refer to the question back, which is 50, and then sigma is 4. So minus with 50 and then divide with 4. Then we can calculate for the value of Z. So we will have the value of Z, which is 2.5. So we will have Z greater than 2.5. Alright. So the same thing, when we have Z, always draw the standardized normal distribution. So this is our standardized normal distribution with the shaded area for the probability that we want to find. Since that the Z value is positive, so it's going to be on the right side. So 2.5. And then it's greater than, so the shaded area is here. Okay, so if we compare this shaded area with the table, so let us put the table. Okay, so we put the table here. So now if we compare our shaded area with the shaded area in the table, it's not the same. So when we are having not the same shaded area, so what we need to do is we need to have 1 minus the white area in our SND table. So our white area is the probability less than 2.5. So 2.5 in the table, the probability is, I believe you can come up with the probability already. So I just give you the probability straight away. So the probability is 0.99379. So means that our answer going to be 1 minus 0.99379. So the answer going to be, so I will write the answer here. So it's going to be 1, 9, 7 is 2, 9, 3 is 6. So 0. Okay, I will erase this one first. So it's going to be 1, 2, 3, 4, 0, 2, 3, 4, 5, 1, 2, 3, 4.0. Okay, so that is going to be the answer for the shaded area, which is greater than 60, which is the weight, probability of the weight more than 60 kilogram. Moving on to the last question. So the last question wants us to find the probability 46 less than x less than 52. So still the same thing. We need to transform the x into z, but now we have two values of x. So since that we have two values of x, so when we transform into z, we also will come up with two values of z. So this one means that we are going to have our shaded area lies between two values. So it's still the same thing. We are going to use the same values of the mu and the sigma just now, which is the mu is 50 and the sigma is 4. So still the same thing. We are going to have the p. So now we transform into the z. So we are going to put into the formula. So our x value is 46. So 46 minus with the mu, which is 50, divide with the sigma, which is 4. Still using the same symbol, which is less than. Once we put into the formula, we are no longer having x. It's now is z. So still using the same symbol, it's less than. So still the same thing, put into the formula. So we are going to have 52 minus 50 divide with 4. Okay, so still the same thing. Once we put into the formula, so we need to calculate for the z value. So 46 minus 50 and then divide with 4. So we are going to have negative 1. So this one we simplify, we have negative 1 less than z. And this one we have 52 minus with 50 and then divide with 4. So we will have 0.5. Okay, so still the same thing when we have the z value. So always draw our standardized normal distribution. So our standardized normal distribution with the shaded area. So one in on this one negative value, one the positive value. So means that one on the negative side. So negative 1 is here. One positive is on the positive side. So 0.5 is here. So then shaded area going to be in between these two values. And then again, when you have in between, so means that probability of the greater z less than minus with the probability of the lower z less than. So means that the probability is going to be the probability of z less than 0.5 minus with probability of z less than negative 1. Alright. Okay, so this is the same thing. So 0.5. So z less than 0.5. So we need to refer to the table. So let us put the table. 0.5. So 0.5 is here. So it's 0.6915. 0.6915. Sorry. 0.6915. So this one is 0.6915. And this one, since that it is negative, so you need to flip. So it's going to be 1 minus. So it's going to be 1 minus less than 1. So 1, again, we need to refer to here. So 1 is going to be 8413. So 8413, 0.8413. And then you can calculate for the values. 0.6915 minus 1 plus 0.8413. So we will come up with the value 0.5328. So that's the final answer for our shaded area. So that is how you calculate the probability using the formula to transform from the real variable value and using the S&D table. And I'm going to see you on the last part on the next video.